All right, good morning, everybody. I'm just going to go through the Tuesday slides from the 14th today. Today, we're going to be talking about power and how power is equal to current times voltage and a little bit about AC and DC current. So, kind of stuff that actually gets used in your home, and it's going to help you on your exit ticket today to calculate actually how much energy is used in your home. So, today, you have your notes. And then we also have the exit ticket today due at 2:30 or yeah, at 2:30. Stop in for the morning meeting if you want to go over yesterday's quiz. So that's what we're going to be doing today. So your learning target today, what you're going to be able to do by the end of this is you're going to be able to solve for the cost of electricity in your house. So power, when we talk about in the electrical sense, is how much electrical energy is changed into other forms. So if you think about like your toaster takes electricity and it changes it into heat, right? And that's what toasts your bread. Or if you have a blender, right? Your electricity is pushing that motor that spins the blades in your blender that chops up whatever you're making. So um, it's changing electrical power into some sort of either thermal, mechanical, chemical. If you're charging like your cell phone, that's an example of going from electrical to chemical in the phone battery. So they're all different types. If you have a speaker, you got light or sound. If you have lights, obviously it's light. So that's what we're going to be looking at today. We actually measure that in watts. So we did this in first try where we measured things in watts or kilowatts for a lot of power is going to be measured in kilowatts. To do that, we actually just take the current and multiply it by the voltage. It's a really simple equation, P equals IV, right? So it's a really simple equation for us to use to calculate power, and it's pretty simple for us to actually calculate how much it costs to charge something or to use something. So there's an example video right down here for this next slide. So the example gives us a 12-volt battery connected in series. That doesn't really matter, but you need to know that there's 12 volts, 3 amps, calculate the power. So the question, or sorry, the video walks you through how to do that and gives you the answer there too. Try it on your own before you give it a shot on the video. When you buy electrical energy, so when you buy it from Xcel Energy or Wright County Electrical Co-op, wherever you're buying your electricity from, energy is going to equal the power times the amount of time it was used. All right, so we're going to take how many watts you had, multiply it by how long it was used. All right, and that's going to give us our energy that we took up, right? So we buy energy in something called kilowatts, right? It's the same thing as a watt, except a kilowatt just means 1,000 individual watts. So 1 kilowatt is equal to 1,000 watts. And that's just because we use so much energy, it's way easier to measure in things like kilowatts. Otherwise, we'd have, 72,000 watts instead of 7.2 or 70 kilowatts. It's just a lot easier for us to use kilowatts. So if we use a 1500 watt heater for 3 hours, how many kilowatt hours of energy did you use? Right? So if we take this 1500 watts, right? 1500 watts is equal to 1.5 kilowatts, right? Because there's 1,000 watts in a kilowatt, so 1.5 kilowatts, right? And how many hours did we use it? 3 hours. I'm no math major, but that comes out to 4.5 kilowatt hours, all right? So that's how much energy we actually used if we use that heater for 3 hours. And then the cost of electricity is 9 cents per kilowatt in this example, right? Sometimes it changes, different times of the day it changes. So, sorry, it's $0.9, which is 9 cents. So if we multiply 4.5 times that price of $0.09, we get our answer. So 4.5 times 0.09, right? It cost us 40 cents. Sorry about that. it costs us 40.5 cents or point sorry 0.045 dollars to run that for that long. Pretty simple for us. And that's how you do it. So you take your kilowatts. So I had 1.5 kilowatts. I multiply it by how many hours it was running. So 3 hours. So 1.5 times 3 gives me my kilowatt hours, and then I multiply that by our price. And that gives you your answer. So you're going to be doing that today. We're going to give you a price, and you have to figure out how much energy you're actually using for 2 devices in your house. So let's say it takes you a half hour to charge your phone. Okay, so that's 0.5 hours. And then you got to figure out how much energy was actually used there. So that's your job today in your exit ticket. Um, just a little bit about current. There are 2 types of current. Direct current is what a lot of our appliances work on. If you have a cell phone or a computer charger, right, they usually have one of these blocks on them. That block is actually an AC to DC adapter. It takes the alternating current that comes out of the wall and converts it into direct current that your computer or your phone can use. Um, Direct current is kind of how it directly flows in one way. It's only going to go from, if you're talking about a traditional way, positive to negative, but if you're talking in the actual way that electrons move, um, you're going to move from the negative terminal through the circuit to the positive because electrons are negative. They're going to flow from negative to positive. Batteries are direct current. They flow from the negative terminal to the positive terminal, right? Alternating current, or AC, right, is alternating because it's going back and forth, back and forth, back and forth. So it switches direction constantly, actually 60 times per second. Think about that, 60 hertz. And that switching back and forth is still movement of electrons, and that's how what comes out of the wall. So anything that comes out of the wall is going to be using, or is going to be alternating current. And then appliances that can run with that don't need an adapter, and appliances that need direct current need some sort of an adapter, like your cell phone brick or block or whatever you want to call it. All right. Your job today is complete that exit ticket. Good luck, everybody. Let me know if you have any questions.